So let's go ahead and talk about the ways that human beings have developed in order to be able to treat fresh water and make it fresh and clean and easy and available for drinking. Okay? Because your community, wherever you live, has a water treatment plant that helps to ensure that the water that's coming out of your tap in your house meets all of the regulations and expectations for fresh and clean drinking water. That's what this section of the notes is about. How does your local water treatment plant ensure that the water coming out of your spigot or spout at the house is fresh and clean for you to drink? So the first thing to keep in mind is that at water treatment plants, they're constantly testing the water, looking at the levels of specific kinds of contaminants. We talked a little bit about that in the previous section of notes. The Environmental Protection Agency has set a list of acceptable levels of certain kinds of contaminants based on the use of any particular body of water. Now, what are some of those contaminants that your local water treatment plant is testing for? Well, they're on the lookout for levels of bacteria in the water. We studied bacteria in your pathogens unit that can replicate quickly and make you sick. They're on the lookout for the level of nitrates in the water that you're drinking. That can come from pollution from both human and animal waste. And they're also looking for chemicals like arsenic in your water. So wherever your water treatment plant is, they're actually taking active steps to measure the level of those contaminants that are inside of any water that you might get close to drinking. That should give you some peace of mind, right? Like the fact that somebody is monitoring the water that you drink to be sure that the levels of each of those things is not too high. That should feel good. Now, why does this matter so much? Well, it matters because there's literally not enough fresh water available and easy to access on the surface of the earth to meet human needs. Let me say that again. We don't have enough fresh water to meet basic human needs on the surface of the earth. That's because much of our fresh water is frozen in the polar ice caps, in the glaciers. That's because a lot of our water is trapped underneath the surface of the earth in aquifers and in groundwater at any given time. So the fact of the matter is, there's not enough fresh water for you to drink. And we know that in advance, which is why we've developed a really clear process for treating water so that we can use it again and again and again. In some ways, it's like recycling water. And that should be good news to you as well. Not only are people monitoring the contaminants that are in water, but we've developed a system to treat water, to take the contaminants out of it so that we can use it again. Now, that system for treating water has some very clear steps. They're outlined on this particular slide. And when we treat water, we actually are removing all of these things. So suspended solids come out of the water when we treat it. We get rid of bacteria, algae. If there's any viruses in the water, we treat that. Okay, we get rid of fungi that might be in the water, minerals, other chemical pollutants. We've got ways to erase all of that from water. And what are those ways? Well, you can see the list of steps right on the top of this particular slide. I don't want to go over those with you one by one here. And that's because I'm hoping that your teacher has done a demonstration for you about water purification using P&G water purifier packets. It's actually a super cool demonstration. If your teacher hasn't done it, ask them to do it. If your teacher hasn't done it, all the way at the end of these slides, you might be able to find a video of Mark Rober, one of the best science communicators of YouTube, modeling the demo for you. But what I want to do is go through each of the individual steps in that demonstration so that I can show you what we're doing when we purify water. The reason that P&G demonstration is so effective is that it actually follows the exact same steps that your local water treatment plant follows too. So let's go over those steps one by one so that you can understand how your water is cleaned for you. So what you saw in our P&G water purification demonstration was some Pretty darn dirty water, right? And what I want you to know is that in that dirty water, there were several pollutants. Some of those pollutants were dirt particles, and you could see those, or other suspended solids that you could see. But if you were to look carefully with a microscope, you would have also seen some of the things in our pathogens unit. You would have seen viruses or parasites or bacteria in that water too. Microscopic things that could still make you sick, even if you couldn't see them. That's interesting, right? And the P&G water purification packet is super interesting to me because it was a product that was developed by a laundry company called Procter & Gamble. And now it's being used worldwide to provide people with fresh water. We'll talk more about the role that P&G has played in that later. So one of the things that's worth knowing about those P&G packets is what's inside the packet itself. And what's in there are a powder that is made up of calcium hypochlorite and chlorine. Now, you're never going to remember those names, and that's perfectly okay. You might remember chlorine because I bet you they use it in your community swimming pool if you happen to go to one. But what's important to know about those two ingredients is that they're also some of the same ingredients that are used in water treatment plants in local communities. So if you were to call up your local wastewater treatment plant, they might tell you that they're using calcium hypochlorite and chlorine too in their water treatment process. Now, the first step in the water treatment process, both in our P&G packets and also in wastewater treatment process, is something that's called coagulation. And what coagulation does or is using a substance that's called a coagulant to remove the suspended solids and dirt particles from a water sample. And they do it in a really interesting way. The coagulant, the material that is a coagulant, is actually positively charged. The dirt particles that are inside your water sample are negatively charged. Now, do you remember when we were talking about the properties of water? Do you remember what we call it when a substance has a clear positive side and a clear negative side? What is that? Right, the answer is those are polar substances. So the coagulant that we're using is a polar substance, and it attracts the dirt particles. And the result is you end up with clumps of dirt inside of your substance. We saw that in class. Do you remember after we stirred up the P&G packet inside of the dirty water, how clumps of dirt started to form? Well, the reason that was working is because the dirt had a negative charge, the coagulant had a positive charge, and they were drawn to each other like magnets. That's awesome. Now, water treatment plants and powders like the P&G product that we used have another substance inside of it called a flocculant. Now, a flocculant is interesting because a flocculant will wrap up the smaller dirt clumps. It pulls together the smaller dirt clumps. Take a look at this image from coagulation, right? The coagulant pulled together small clumps of dirt because the coagulant was positive, the dirt was negative. Now you've got small clumps of dirt. The flocculant will bring those small clumps of dirt closer together and wrap them up into larger clumps of dirt. Now, those larger clumps of dirt are called flocks. That's where the word flocculant comes from, or flocculation comes from. And eventually, those larger clumps of dirt, those flocks, become slightly more dense than water. And when something is slightly more dense than water, what does it do? It sinks. And we saw that, right? We saw those larger clumps of dirt slowly but surely sink to the bottom of our pitcher in class. Now, when flocculation was finished, our water looked pretty good. I mean, there was a layer of brown stuff at the bottom, that's for sure. Those flocks were all sitting on the bottom of the water, that's for sure. But the top of our pitcher, the water looked pretty darn clear. And I would have thought that if I would have taken like a cup, I could have dipped it into our pitcher just up at the top, taken out some of the water, and drank it and been just fine. I mean, it looked pretty clear to me anyways. However, what's important to remember is that even though the flocks are on the bottom, the flocks were just the suspended solids that were in the water. It was the dirt floating in the water, or the mud floating in the water, or whatever other dirt, solid particles were floating in the water. Now, coagulation and flocculation has removed those suspended solids from the water. However, there are still contaminants even in clear water. That's why you can't really just go to a stream or a creek and see that it's running and say, hey, I'm going to drink that, looks good to me. Because some of those other contaminants, the bacteria and parasites and viruses, you can't see them with your eyes. You know that. We called them microorganisms in our pathogens unit, right? It's not always possible to see and or to smell the microorganisms that are in the water, the dangerous contaminants that can also make you sick. So even though the top of our pitcher was clean, if you paid attention, I didn't drink that water yet. The third stage in our P&G water demonstration was to chlorinate the water. The P&G packet includes what's called time-release chlorine, which means it isn't released until later. And so now you've got coagulation and flocculation happening, taking away the suspended solids, at which point the chlorine is released. And when you release chlorine into water, you kill 99% of all of the viruses and parasites and bacteria that are in that water. And I actually said it wrong. If you look at the slide, you actually remove 99.9% of all of the viruses, parasites, and bacteria that are found inside of dirty water. Now, chlorination is the most common strategy that we use in wastewater treatment plants too. You call up your local wastewater treatment plant, they're probably going to tell you that they use chlorine in order to kill off the unseen contaminants in water too. It's by far the most common strategy we use. It's not the only strategy. You can actually kill off things like viruses, parasites, and bacteria with ultraviolet light too. So a wastewater treatment plant could treat their water with ultraviolet light instead of using chlorine. But the vast majority of wastewater treatment plants use chlorination because it's an old, established technology. Like, we know how to do it, and we've been doing it for a long time. Now, once the water's been chlorinated, we're really ready to drink it. It legit is fresh, clean water that we're able to consume. The only thing we got left to do is get rid of the flocks. In class, we did that by stretching some fabric over the top of a second pitcher and pouring the water through. And the water went through the fabric, but the flocks were caught on the top of the fabric. They don't use fabric in pitchers in wastewater treatment plants, but the last step in the wastewater treatment plant too is to get rid of the flocks and find a way to dispose of that material, right? You don't want that in your drinking water system. You're not going to put it back in the river, so you've got to figure out a way to dispose of the waste that you have after coagulation and flocculation. However, that last step, once you've chlorinated your water and gotten rid of your flocks, you really truly have pretty clean water that you can go ahead and drink. If you're in my class, you're going to see me drink it, right? Like, you actually watched me do it. And I'm not kidding you, it tastes just fine. It's so interesting to me to have filthy water that becomes clean because of that one packet of powder. But that's what's happening in your wastewater treatment plant too. Because we don't have enough fresh water available to everyone on Earth, we have to treat the fresh water that we have available to us and use it again and again and again. It's cool, right? Now, this has nothing to do with our notes, and it won't be on our test, but I just wanted you to know how amazing Procter & Gamble really is. They didn't develop this product simply because they were trying to figure out a way to clean water. They really accidentally stumbled on this product because they were trying to find a way to pull dirt out of laundry water. It was just kind of an experiment happening within their company. When they realized how well it worked, though, they realized that this could be a game changer in poor communities around the world where people don't have access to a wastewater treatment plant. You and I don't have to worry about whether the water we drink is clean. There's big plants that process thousands of gallons of water every single day, and all we got to do is turn on the tap to get it. But in poor countries around the world, that's not true. Sometimes people walk for hours just to try to get to a clean water source. They literally spend their days hauling water back and forth. Girls, in many of those poor countries, the people that are hauling the water are girls and women. So they don't get to go to school because they're too busy trying to go to a clean water source and find something for their family to drink and then bringing it back. Well, what P&G realized is that with one simple little packet, a person could take what we would consider to be dirty water, treat it, and then drink it without having to walk back and forth and haul that water, right? And so that technology, that one simple packet that a laundry company fell upon, has ended up changing lives for the better. Because now if you live in a place where access to clean water is hard, maybe you don't need to access clean water. Maybe even your dirty water plus a P&G packet is going to give you something to drink. And that's huge. Because you may not know it or not, but hundreds of thousands of children, kids just like you, die every single year because of access or lack of access to clean water. That boggles my mind, guys. Literally 365,000 kids per year die because they don't have access to clean water and they end up with a waterborne disease or a waterborne pathogen. I know it may gross you out, but the most common waterborne pathogen that people get is diarrhea. And kids literally die from it in poorer countries around the world because they're not drinking clean water. It's amazing to me. And I feel like it's something that we ought to think about. P&G, they take their packets of water, like those P&G packets, and they're actually selling them for a loss to companies around the world that provide support and relief to people in very poor countries. They sell their packets for less than 50 cents per packet, which is less than it actually costs to make the packet, to societies and organizations that help the poor in developing countries. I actually think that's a remarkable corporate gift so that we can help to protect the lives of people who don't have access to clean water on a regular basis. Well, why do I share that with you? Well, go out and buy some Tide. I mean, let's give back to a company that is helping to keep kids alive in the poorest countries of the world who don't have access to clean water, right? All right, anyways, I'm getting off my soapbox. Bye now.